So the first thing it's going to do in section 4.2 is it's going to give us an ordered pair, and they're going to ask if that ordered pair is a solution to a particular linear equation. So let's just think about what that means. If an ordered pair is a solution to a linear equation, what is a linear equation? What does a linear equation make? A line, right? Thus the name linear. Has the word line at the very beginning of it, okay? A linear equation makes a line. So this right here is a line. And this ordered pair is it's a coordinate. It's a point, right? So what do you think it means to ask, is a point a solution to a line? You plug it in, but what does that mean in relation to that graph? Is this point on this line? That's what it's asking. Is this point on this line? Okay, so we don't have a graph to look at, but we want to determine is this point is on this line. And the way we do that is what y'all are saying. We're going to plug in and see if the solution is true. See if it's a true statement. Okay, what are we plugging in where though? Right. If we have a coordinate, we have an ordered pair, we have an x and a y, don't we? Right? So if we plug 1 in for x and -4 in for y, and it equals 7, then that means it is a solution. If it doesn't equal 7, then it's not a solution, which means that point's not on that line. Okay? So let's do that. Here's my equation, 3x minus y equals 7. So I'm going to say 3 times 1 minus -4 equals 7. I'll use parentheses so that I wouldn't forget one of the negatives. And then I simplify it. What's 3 times 1? What does minus -4 mean? Plus 4. Does that equal 7? Yes. So is it a solution? Yes. Is that point on the line? Yes, that point is on that line. So that's what that means. Any questions about that? So we're going to do the same exact thing for problem B. They give us the point 2, 3, and they're asking if that point is a solution to the equation -x plus 2y equals 8. It's also the same thing as asking, is this point on that line? So what goes in for x? Well, 2. Yeah, it's just plain. So it's I'm going to say negative parentheses 2. Plus 2 times 3. And I want to see if that equals positive 8. So that's -2 plus 6. Does that equal 8? No, it does not. So is this a solution? No. Is that point on that line? No. So you'll have a few of these on your assignment today. Does anybody have any question about how you're going to work that? We good? So you're going to plug in the x and the y. If it's true, you say yes, it's a solution. If it's false, you say no, it's not a solution. Okay. And then we get to graph. Now this is very similar to what we just did, except for a few things are different. What's different about the ones that we did in section 4.1 from this one?
We don't have the domain.
They did not tell us the domain, did they? No. You know what that means?
You use your own one.
We get to pick our own numbers for x. Okay? And my rule is some teachers are mean and make you do 5 x's. I'm going to make you only do 4. So if they don't tell you a domain, you get to pick your own. There's one other thing that's different. Well, 2, because they didn't ask us for a range. One other thing is different. It's not in slope-intercept form. It doesn't say y equals. So if it doesn't say y equals, then the first thing we have to do before we make our table or anything is get it in slope-intercept form. And we had a lot of practice doing that at the end of chapter 3. So what are we going to do first to get this one in slope-intercept form?
Add 2x.
Add 2x. And actually, that's the only thing we have to do to both sides. So that gets me y equals what?
2x minus 4.
Very good. So you keep the same sign, positive or negative, as what's in front of them, and you just make sure you put the x in front of the y-intercept. So any questions about how we got that in slope-intercept form? Okay. So we want to pick our own x's. Now, y'all, we're going to be smart about how we pick our own x's, because we only have little small pieces of paper, right? And I have even fewer grids on my screen as you do on your paper. So we want to pick numbers that's going to make us have the smallest graph possible, right? Because I don't know about you, but I don't want to be graphing points that are like 10, 152. Okay? So the best way to do that if you get to pick your own is pick x's that are close to 0. So my 4 x's I like to choose most of the time are -1, 0, 1, and 2. I don't know why I made that so long. So most of the time, and I'll show you a little bit later when I don't like to do that, but most of the time I want to pick -1, 0, 1, and 2. And then I'm going to make my table just like I did before. My line getting so long. And then just like we did a while ago, plug in my -1 for x and do my arithmetic. So what is 2 times -1?
-2.
Minus 4.
-6.
Yes. And then 0 makes life easy. 0 minus 4 is -4. 1 is also pretty easy. 2 times 1 is 2. Minus 4 is -2. 2 times 2 is 4. Minus 4 equals 0. So are there any questions so far? Okay, when you make your graph, look at your coordinates to see how to make your graph. For example, I'm noticing that all of my y values are negative numbers or 0, right? So I don't care much about quadrant 1 and quadrant 2 on my graph. So I'm just going to make those very small and make my graph kind of bottom heavy, I guess you would say. So I'll have more going on probably in quadrant 3 and quadrant 4. So left 1 down 6. 0, -4. 1 down 2. And right 2, stay on the x-axis. Arrows. Did it ask for the range? No. So if it didn't ask for the range, I'm just going to stop after I make my graph. Any questions? Is that pretty easy? Y'all want to see another one, or you want to skip the next example? Okay. We will. Let's look at the special cases. This one's different. What's a little bit different about this one? We only have y. We don't have x, right? Okay. Does anybody remember anything about a graph that only has a y and no x?
It's always going to be straight.
All lines are straight.
Well,
Except for when I draw them. Mine are crooked. Do what? Close? Yeah, that one. Okay. So, yes. What this means is we're going to have a graph that crosses the y-axis at 2. There are no x values. Okay? So, there will be x values, but there's no x in the equation. So let's just make a table just because that's what we've been doing. We get to pick our x's. Let's pick my common 4, -1, 0, 1, 2. And the equation says y equals 2. So that means no matter what x is, y is always going to equal what? 2. So I'll just fill in 2's. And I got those 4 ordered pairs. So graph those 4 points. I'm going to graph mine in blue so you can see it better. Left 1 up 2, 0 up 2, 1 up 2, 2 up 2. So yeah, it's horizontal. Where is it crossing the y-axis at? 2. So y equals 2 is a horizontal line that crosses the y-axis at 2. So the equation kind of tells you what it's doing, right? Y equals 2 means we're crossing the y-axis at 2. And you just have to memorize that it's horizontal. So y equals a number is going to be a horizontal line every single time. So if this is a multiple choice question and it has 4 graphs for your solutions for you to choose which one it is, and there's only one horizontal line, do you really have to think too hard? No. So just memorize that y equals a number is a horizontal line. So what do you think x equals a number is? Vertical line. Yeah. So y equals a number is going to be horizontal. X equals a number is going to be vertical. So this time it says that x equals -1. That means x always equals -1. So all your x's will be -1. So what do you think we're going to do for our y's then? Make them up. Whichever ones we like best. I'll just stick to my standards. -1, 0, 1, 2. Keep my graph small. Okay, so that's the only time you get to pick your y's instead of working something out is when it says x equals a number. Okay? Where do you think we're going to cross the x-axis at? -1. Yeah. So left 1 down 1. Left 1 0. There we go. Yep. So x equals -1 is a vertical line that crosses the x-axis at -1. So write that down, highlight it, memorize it. X equals a number is a vertical line. Any questions? Simple. Okay. Y'all write down this one. Just because it's slightly different. Actually, this. Nope, sorry. What did I write down there? Swap those two. No. A 4. Do that. Sorry. So what are we going to do to this one first before we make our table?
Make it slope intercept.
Make it slope intercept form. So y'all help me do that. What am I going to do? Subtract 2x. Very good. And then I have 4y equals what? Plus 8. Then what do I do? 1 by 4. Y equals what? Plus 2. So simplify your fractions all the way. Okay. Now, we get to pick our own x's, don't we? All right, let's pick some smart x's. We're picking our x's. And I have a fraction that I have to multiply by x. What kind of x's do I want to pick? For this one, evens, right? But what if it was negative 3/4? What would I want to pick? Not necessarily odds. Yeah, okay. So if you have a fraction, y'all, pick x's that are divisible by your denominator. There's your little hint. Because if you pick x's that are divisible by your denominator, and then you add a whole number, then you should get a whole number. Or if you subtract the whole number. So on this one, since we're just multiplying times a half, it's divisible by 2. We want numbers divisible by 2, which would be small, even numbers. So which x's do y'all think we might pick specifically? Yeah, and sure you want to do 0 in there, right? 0 is easy. So yeah, I'd pick those 4. So number 1/2 x plus 2. So first I plugged in negative 2. Negative half times negative 2 is positive 1. 1 plus 2 equals 3. And then I do 0, and it's simple. 0 plus 2 equals 2. And I do negative 1/2 times 2 plus 2, which is negative 1 plus 2, which is 1. Oh, that's supposed to be a 4. Sorry. Negative half of 4 is negative 2 plus 2 is 0. Using that little trick, picking x's that are divisible by your denominator if you have a fraction will make your life a little bit simpler, okay? So left 2 at 3, 0, 2, 2, 1, 4, 0.